Hello everyone, welcome to the NN Classroom. Today, I'd like to share with you a past paper question from 2019 Time Zone 2 in May, question number 5, relating to the concepts from topic 2, atomic structure, especially about the energy level diagram in constructing all those principal quantum numbers and express the energy levels, right? Let's see. Which of the following transition in the hydrogen atom will emit, the keyword emitting the least amount of energy, that means the energy need to be minimum, and it is going to be emitting simply means you must be going from higher to lower level, right, according to the law of conservation of energy, because things or electrons moving from low to high energy need to absorb energy, right? So that remember the keyword emit, right? So all these are from higher value to a lower value. That makes sense. So that should be possibility of the answers, right? But then what is going to be tested on is that whether students are knowing that our energy level diagram is actually following two pretty famous features, right? The first feature is what we call discrete idea. That means the energy level that we must be constructing is based on fixed energy level. That means not fluctuating. So this is the first key idea that brainstorm from that emission spectrum or line emission spectrum. And the second major feature, the second one, which is the thing that is being tested this time, is about what we call the convergence limit. Yeah, so that means the energy level is actually increasing when you go to higher level, makes sense? But the increment is actually decreasing. What that means? That means when I say, for example, this is going to be n equals 1, so that is the first level. And the second level should be higher, that makes sense, supposedly n equals 2, right? But then if you go to energy n equals 3, you are going to be having a higher value, but the increment is now diminishing, like here, for example, right? That means the delta E, that means the energy gap is like now getting closer. That means smaller the gap, right? So that is what we call the convergence limit. So this is the key idea that to be tested for this time, right? So when you go to energy n equals 4, that is even smaller in terms of the magnitude of the increment, right? So for now, for obviously, and when I sketch up to n equals 4, that should be enough because the question now only focusing within n equals 1 to n equals 4, right? So that's why for A, as you can see, for electron, then moving from n equals 2 to 1, so that means this is the gap we are looking for, right? So this is the choice A, right? As you can see, the gap is quite large, may not be the case, but let's compare. For B, from n equals 3 to n equals 1, obviously, from n equals 3 to n equals 1 should be a bigger number, bigger energy value involved. That makes sense because we are now moving from 3 to 1, that is like all the way with n 2 to 1 and then 3 to 2 as well. So that's why B cannot be the choice, right? Because A is now getting smaller, right? And for C, what you are moving is from 4 to 2, right? It seems like that for 4 to 2, you are now moving across 2 of the energy levels, right? So that's why it's just comparable between A and C, right? So both are kind of small value. But then there's a much better choice. So that is from 4 to 3, right? As you can see, from 4 to 3, this is going to be only within one energy level movement. And that is particularly much smaller because thanks to the concept of the convergence limit, right? Yeah, so in this case, as you can see, right, from 2 to 1, still moving within one energy level, but versus 4 to 3, still moving between one energy levels, right? But the energy difference is much smaller because of this convergence limit. So obviously, the answer for this case is not A and not C anymore, although they are kind of comparable. But the best choice in this case should goes to D, right?